Welcome, everybody. Great to see you. We knew that when we chose August to do this series, it would be peppered with people going on holiday, etc., etc. So it's great to have you here tonight and lovely to welcome you. I think most of you know, but just in case you don't, the picture, the logo that we sort of started with, the guy looking out to the distant mountains, seeing adventure and discovery before him, was we felt was quite a good kind of model for this course. We want you to think of it as an adventure. For me personally, learning about stuff has been one of the great adventures of my life, and learning about ultimate reality has to be the most exciting thing of all. You know, it's a kind of journey that probably never ends. So that kind of sets the scene. The logo of the man hunching his shoulders and looking like he doesn't really know anything also we felt was quite important, because it reminds us that you don't have to buy into anything to come on this course. It's for everybody really that wants to ask a question, and we're going to attempt to give some serious answers. You might not agree with everything that we say, but we hope that it will be stimulating and helpful, and who knows, you might come to some good answers as well out of it. Okay, so we're on to number 3 tonight, and the subject that we're taking is the question of evolution. Now, you may say, why would you take this theme? I mean, particularly if you're thinking about God or ultimate reality or whatever, why would you take theme of evolution? I mean, surely this is a fairly scientific thing. This is to do with biology and it's physics and all these other things. Shouldn't you, I've had people say to me, what are you doing all this kind of stuff on scientific things? And the reason really is partly this man. Not entirely. I mean, he's a symbol really of many others that would stand with him. And you'll notice on his T-shirt, religion, we can find a cure. He is one of the most avid anti-Christian evolutionists that there are, but he would not be alone. There will be many people who, like him, have imbibed the view of evolution that has made him quite hostile to the very idea of God. And I mean, that's one of his quotes. I mean, there's loads of others. He's written the book, The God Delusion. Evolution has enabled me to become an intellectually fulfilled atheist. So you have to say it is relevant. That the two have become connected. There is something about the theory that undermines some of the fundamentals of the Christian faith, and in fact all religious belief, I guess, in the end. It has actually been taught in every major branch of learning and impacted upon it. In fact, it would be hard to do any of those subjects that are up there without imbibing some kind of an evolutionary philosophy, an evolutionary worldview, a paradigm, if you like. It has affected profoundly the politics of the 20th century. It's not always recognized that both Stalin and Hitler were both ardent believers in evolution. I mean, Hitler, obviously so. He believed in the Aryan super race. He believed in the survival of the fittest. He felt that he should help the process along. He shouldn't just leave the less fit to die on their own. He should help them along. And so he had gas chambers and the whole thing. Everybody was a bit, reacting against that and pulled back from it. But he was not alone in that. During that period, in both America, in the West generally, in Europe, in Australia, there were all sorts of experimentation going on with mercy killing and eliminating people that were considered to be not fit, and sterilizing those that were considered not fit to have children, and so on and so on. So, I mean, it was quite widespread. Much society had bought into an evolutionary worldview and felt that we needed to, this was a good thing. We don't want the unfit to survive. We don't want ignorant people to have loads and loads of children. That was the kind of idea. So if we cut down the birth rate and let the more select people have children, then of course you up the level of the human race. So there was a lot of that going on. So Hitler was part of his time and part of a general thing. Stalin, of course, also loved it because it advocated atheism and gave an intellectual credence to the fundamental atheism that he believed in and that undermined communism. As we said earlier on one of the talks, I mean, these two men between them and their ideologies they stood for have been responsible for the deaths of millions of people. in the 20th century. So you can't say that this is a minor thing. What we believe does affect ultimately our behavior, even though there may be a small overlap time while that's happening. And Western society still is totally committed to an evolutionary worldview. Where that will end us up, we shall see in time, but there are already some slightly worrying signs of it. It also has impact on the more subtle sort of soft things. I mean, it's interesting that Monty Python, I mean, they did a thing, didn't they, The Meaning of Life, but it's interesting to me that they've emblazoned it on a tombstone. The implication being that the meaning of life has died. And I thought about that, and I thought, well, that's almost a parable for modern man today. I mean, everything is alive, but we have no sense of meaning about life. There's no sense of what it's about, what it's for, apart from our own narrow thing. And of course, again, Dawkins, will bring him on, says it all, doesn't he, when he says that? The universe that we observe has precisely the properties, it doesn't, but that's what he says, that we should expect if there is at bottom no design, no purpose, no evil, no good, nothing but blind, pitiless indifference. Now that made him a really self-fulfilled atheist, but it doesn't do a lot of good for a lot of other people. And the human spirit, I suspect, has suffered greatly from this ideology that has settled upon us. It draws a big question mark over a sense of meaning and destiny. What is my life about? Where have I come from? Where am I going? Is there a purpose in it? And so on. It also questions of identity. Who am I? Where do I get who loves me? How do I get my worth and value? I sometimes wonder if there are not millions of young people that want to be stars and want to get on, all the sort of talent shows on television to somehow find a sense of meaning, of identity, that I'm worth something. So there are kind of signs of this malaise running through it. Self-worth, well, we've already talked about that, and morality. I mean, he says here, there is no purpose, no evil, no good. So Hitler's not evil. You know, you can do anything you like. There's nobody making the rules up. Now, he would say that he lives by the rules, but I mean, this really says it all, that if there is no God, if there is no judge, if there is nobody to set the rules, who makes them? Well, we make them ourselves. The government makes them, really, as far as I can see at the current way. So morality is out of the window. Every man does what is right in his own eyes and so on. Now, it seems to me not an accident that running along in the back of this, in 20th century Western society, where we've got so much, really, in terms of materialism and everything else, there is a slow-burning mental health crisis coming into being. I mean, lots of young people are often the biggest victims of this. So that there's more suicides. More young men commit suicide now than any other category of people. There's self-harming. There's dietary problems. There's depressions and all kinds of things that young people are, when they're at the beginning of their lives with everything in front of them. And I have to say, it seems to me would not be at all surprising if this fundamental spiritual vacuum that we're facing isn't a part of that. So what then is the theory? Well, that's it in picture form, that there is a kind of chain of life, that it started way back. If I can just look to that, you'll see down there's the proto-cell and the very first life forms. We're all a little bit vague about that. Nobody quite knows what they were. What's a proto-cell? Well, who knows? But that's 4 million years ago. We do know that absolutely, definitely, and certainly. And so through all those millions of years, I mean, actually, most of it, you know, you kind of, most of the time, you're going through all these sort of reptilian creatures. You don't get to anything sort of like attractive and fuzzy until like millions of years down the thing. So it's all kind of forward. That is the theory then. And if I were to put words into that, it is the idea that all life has developed originally from simple chemicals and all the varied life forms up to and including man himself. And this has been accomplished through the pressure of external factors, sifting the less fit so that the most well-designed animals go on to reproduce and evolve further and further and further. So it's an internal process. Stuff is happening, things are slowly changing from one to another, and the external environment is helping to push that progressive progress along, because only the fittest survive. So the fittest survive, so the fittest will gradually rise to the top and so on. You can see there's a kind of logic to that. Much of it has been driven, I suppose, by the fact that there is enormous similarities in loads of creatures. I mean, that particular line of creatures there, from a chicken to a dinosaur, has obviously been art worked in. You know, I don't think all those creatures in the middle of the process are necessarily live animals. It just shows how easily an artist can give you an impression of it. But the fact that so many creatures are like each other is what I suppose has driven it. They must be related if they're like each other. You know, dinosaurs have got feet like chickens. So although they might be heavy and lumbering, obviously they are the dinosaurs are our chickens really are just sort of modern shrunk down dinosaurs, a lot lightweight. So, you know, you can see these similarities, and you can see the monkeys have got hands like humans, and so on and so on. So it's not difficult to say when you look at a monkey, well, he's pretty close to a human. All creatures have got lots of similarities in their internal chemistry. I mean, they say that 80% of human genome is in the monkey, or is it 80% of the monkey in the human? Not quite sure, but I mean, they often come out with these figures. I don't know how they've actually worked that out. All that would be less startling when you realise that we've got 50% of the genes of a banana, which is not often said, you know what I mean? It sounds a bit ridiculous, doesn't it, to say that, but there you go. So similarity of form has driven it, and so the idea is, well, everything is related. Well, it is related, but it's not related because one grew into the other, but all of them came from the same creator, the same artist, the same engineer who's used similarities, program repeats, etc., just as any engineer would do. I was thinking about the evolution of a Volvo. I think if you applied the same kind of thing, you could look at a whole number. Now you can see those are all Volvos, can't you? How can you see that? Well, you can see that diagonal stripe on the front, isn't it? That is really a giveaway. But there are lots of other things about those things that are actually quite similar. If you were to list them, you would find that there is probably, if they had DNA, 50% of it would probably be in the motor driven. They're all diesels. And when you think of the systems that involve that, it's quite complex, much more complex than a few body panels. So you could say that 50% of your those Volvos was similar DNA. You could say that 10% of the DNA was in the fact they've all got wheels, they've got pneumatic tires, you know, for those that don't know the technical stuff, that means blown up, like with a pump. They've all got that kind of stuff. They've all got mirrors, windscreens, and glass stuff around them in more or less similar kind of places. So although superficially they're quite different from one another, if you wanted to, you could make an evolutionary line from Volvo vehicles. Of course, and they've got a lot of other ones. I've only put 4 there. If you put all of them in there, you could make a whole relational line of Volvo vehicles. And of course, I've given 5% for the diagonal strip on the back. That is a real sign that they are totally one from the other. You know, how could you possibly have that diagonal stripe if one hadn't grown into another? We may not know which one grew into which. Was it a smaller one grew into a bigger one or whatever? Probably we'd say smaller grew into bigger, but not necessarily. But we are pretty certain that they've come out of the same stable because they are 75% the same DNA. I'm joking a bit. But that is really the logic that we're actually dealing with, that because everything kind of looks similar and you can arrange it in a line, you can put it in a row, you can graduate one from the other. Obviously, one grew into the other. And loads of studies of animals and creatures is a question of doing that. And they say, oh, we found another one that goes in the middle of that. How amazing is that? That must be the cousin of that one and the auntie of that one, and so on and so on. Okay, so evolution then is now the cultural orthodoxy. It is so strong now you can hardly stand against it. It is repeated endlessly in the media. Any nature program will repeat it endlessly. I don't think I've heard of a nature program recently that hasn't talked in terms of evolution and millions of years. So it kind of browbeaten into you. You slowly get it to the point that you can't imagine how it could possibly not be true. It's taught to children at school from quite an early age. One of the first things that children are interested in are dinosaurs. So that makes a really good hook. And they find out at infant school, at the very primary school, that dinosaurs are millions of years old. In a story. When are they ever going to question that? That's fact. We know that. We were cavemen. We've evolved. We've come from being cavemen, and look at us now. We're modern Western people. So children are taught from very early on. It's reinforced at university and college. And we have evidence that professors in universities, if they break ranks on this particular issue, they're quite likely to lose their livelihood and be sacked. It is really that strong now, and it has to be taught in school. No other alternative can be taught in school. If you question evolution in a school context, I think the government has said that you can't bring in any kind of alternative. So what I'm doing here tonight is really quite seditious. In the not too distant future, I could get arrested for this, but at the moment, I think I'll probably be all right. The question is, everybody accepts it, it's culturally there. The question is it true? That is the question. That has been my quest. That is what I've been working on for years. Now, there are many scientists now that say it is not true. They are not heard and are hardly repeated and can't get the publicity. This book was written a few years ago now by Australian scientist Michael Denton, and he entitled it Evolution, a Theory in Crisis. And he's not a Christian. I don't think he's even a believer. I mean, he said at the end of the book that he thought that we might have been seeded from outer space. You know, that somebody had come in on a car, which, you know, slightly undermined him in my eyes. But I have to say, the critique that he gave of evolution was extremely good. And they were all scientific problems. They were scientific problems. You would think that scientists would at least listen to scientific problems. So I picked out 4 that I'm going to share tonight that is really the heart of what I'm going to say. Number 1 is the evidence of complexity. We've touched on that a little bit. Hopefully we'll look at it again. Secondly, we're going to look at mathematical probability, or improbability as it ought to be, that you can work out mathematical probability. There are people that know this stuff, like mathematicians, I suppose, and work out the likelihood that something will happen or whether it won't happen. It is so stacked against evolution, you would not believe it. So mathematical probability. Thirdly, the stability of species. Whatever evolution says, we find, in fact, in reality, in everything that we study, that species are amazingly stable. They do not easily change from one to another. And then fourthly, for those of you that like a bit of a long word, we're going to look at the second law of thermodynamics, which again is one of the most recurrent physical laws that is known in the universe. Okay. Each of these, in my humble opinion, is fatal to the theory of evolution. All of them together are, in my opinion, a death blow. I cannot comprehend how this theory has lasted. It nearly died, and then it got a kind of fresh leaf of life halfway through the 20th century. And my own view is that it's driven by the desire of many people to not believe in God. But we shall see as we go along. Okay, so evidence of complexity, first of all. I mean, you don't need me to talk through that. We did it a bit in the first session. I mean, in every direction you look at, there are these amazing things. I mean, gannets are one of the largest birds in the Northern Atlantic. They've got a wingspan of about 2 meters full grown when they fling right out, but they can dive at 60 miles an hour into the ocean. They are totally adapted to do that. They need a whole lot of adaptations. They've got a pad on their skull, they've got coverings that go over their eyes. So you can imagine hitting the water at 60 miles an hour. They can tuck their wings back, they fly and get up to this massive speed, tuck their wings back at the last minute and then dive. And they dive really deep into the ocean, then carry on flying with their wings once they've actually moved into the water environment. Incredible, really, the adaptations and the complexity that there is in these birds. You look at a human eye, amazing that we're able to see everything in full color, HD, wide angle, instantly developed, movie, with a capacity, 3D, with a capacity that no camera, even these ones here, can probably equal. I mean, the eye is a complete masterpiece. There are 2 of them in stereo, and they even look nice. How good's that? The monarch butterfly, well, I've already done the monarch butterflies thing, that over 3 generations it flies the whole way from Mexico across the United States to Canada, then turns around and comes back. Each new generation carries on the journey the one before did. But between the 2 butterflies, there's a worm and a pupa and a few other things to muck up the system. How did the butterflies pass on to the next one where they've got to? I find it incredible and amazing. So there is complexity everywhere. Chickens, what about chickens? I spent a bit of time reading about chickens. Their eggs, they're all in a line. How do they carry all those jolly eggs in there? You'd think it'd be absolutely, totally full of eggs. They come all in a neat line, and as they go down, they all kind of go through their, you know, they have their egg and whatever, and then they harden as they get near to the bottom. I think when they fall, they're still a bit soft. So hopefully don't break and they lay scrambled eggs, kind of. But I mean, they just keep churning them through. They're amazing. So there you go, complexity everywhere. But there are 2 dilemmas. I mean, there's such a lot you could say. I'm just going to try and raise 2 issues that evolution faces in order to bring about this complexity, and it fails well and truly on both of them. The first one is, how do you start it in the first place? I mean, Darwin's original theory was about the survival of the fittest, the evolution of species. He didn't say how you started and how you got the first one going. And so how do you actually start the process going? How do you get the first thing that is living? That's the first thing that I want to try and look at. And then secondly, how do you then add to complexity? If you look at that thing there, you see, you start with your first true cells. They don't put on how they come. You have to start with them before you could ever get anything going. And then they branch out into the tree and go right the way up to a biologist at the top there, reading his book and obviously fully evolved. Now, in order to get from the first basic cell or from a jellyfish to a biologist or any human being, you've got to add a huge amount of complexity into the DNA that was quite complicated to start with. So we don't know how it starts, and we don't know, once it starts, how you keep evolving it. Nobody actually knows how evolution works. I mean, top scientists are wrestling with it and trying to find out how it works, but they have not yet managed it. So first of all, how did life start? Well, the first possibility was amino acids. I mean, you don't worry too much about that. Amino acids well, they look like popper bleeds. They are, oh, there you go. They're chemically comparatively simple. You can see there, that's the sort of thing. There are 20 that go to make up the human life. And I think probably all of life probably has that 20. So there are 20 different amino acids that form everything. So it was thought, I mean, they could be, in fact, I think it was the amino acids that were termed the building blocks of life. They seemed so simple. You only needed 20 of them. With 20 of them, you could build a human being. You could build anything. Everything's got amino acids in it. And certainly all biological life has. In 1952, these 2 guys, Miller-Urey, did an experiment where they gathered a kind of a methane, environment, what they thought the early Earth would be. They put a sort of a lightning spark in the middle of it, and they found at the end of it that they got some amino acids. I think they got about 5 different amino. They thought, this is amazing. That's when you got all the publicity about saying they got life in a test tube. But it didn't happen like that. There were some very big problems with amino acids. Number one, as soon as they got exposed to any oxygen, they died. They oxidized, they couldn't survive. They needed a cell structure to survive in. So that was supposed to be the first thing you started with, but you can't start with it because it needs a cell around it for them to survive. So they couldn't survive. They were destroyed by the atmosphere. What is more, amino acids in living systems are all left-handed. Now, that might not mean a lot to you, but just as you've got a hand that is a right hand and a left hand, so amino acids come in 2 hands. Normally, in a natural environment, they will be equally right and left-handed. For some reason that nobody knows, I think God's just having a bit of a laugh, really, but, in biological systems, they are all left-handed, and they have to be. If you mix up with right-handed ones, the whole system doesn't work. What is more, they are arranged in a code form. In other words, it's not so much what it is, it's the order that they come in. It's like DNA. It's the order that it's in that is the important thing. That's what actually the thing. So, and then they found that actually you couldn't go anywhere with it. You know, you've got a string of popper beads there, but you can't actually get a string of popper beads. You can't get them to join together in order to form into a protein unless you've got a protein machine to do it. So again, you've got a chicken and egg problem. How do you get amino acids if you need all this other equipment to get them going? So there's a protein machine. Are you with me so far? A protein, that's called a ribosome. Now, I mean, that's a fairly oversimplified thing, but you can see that fed in at that point is the messenger RNA. That comes from the DNA. The DNA sends a message, a little string of messenger RNA, and says, I want you to make a protein. So the messenger RNA comes into that side of the ribosome, and then these transfer RNAs, they also come from the DNA. I mean, the DNA is really amazingly brilliant. It sends these things at just the right order, so they come in and they link in. Do you see they've got little shapes there? They're exactly the shapes of these things, so that they actually physically fit. So the RNA that comes from the DNA actually specifies the order that the amino acids join together. So these are not just popper beans of loads of different colours, because they're not really loads of colours anyway. They're not just popper, there are 20 of them that come in a strict coded order. It's the order that is the crucial thing. It is not what they're made of, it's the order that they come in. So the building blocks of life that were thought to be, wow, we've got the building blocks of life, we can do it now, they found actually you can't do it. They couldn't get it to start anything. They were just left with amino acids that started being fairly simple chemicals, and they ended up being simple chemicals. They needed the messenger RNA to provide the code. They needed the transfer RNA to gather the amino acids. It all comes from the DNA program, which is produced by more proteins. There's a whole string of proteins that work on the DNA, that break away the messenger RNA, that do this, that. They're all little workers. They're all working there. There are so many machines in a human cell, you would boggle your mind out. I've got a few of them to show you just for the fun of it, but I mean, it is so complex. There isn't a simple answer to it. You can't start with amino acids. Okay, so that's been largely abandoned. Now scientists are looking for something else that might be the beginning of it all, but thus far they have not managed to find it. Now there's a molecule that most people know about, hemoglobin. Do you all know about hemoglobin? That's in your blood. That's what makes your blood go red. I mean, hemoglobin is an absolutely amazing molecule, and you can see the way all the little popper beads have all been, you know, folded and minced around, and they formed into a shape. I mean, hemoglobin is a 4-segment shape. So they've color-coded it for us. Each one of those segments has got one iron atom in it. You need iron in your blood because iron is the magic thing. So there are 574 amino acids in one hemoglobin molecule. There are about 270 million hemoglobin molecules in one red blood cell. I'll say that again, 270 million. I read that on the internet. I thought, no. 270 million of these, there are about 10,000 atoms in that. So it's not exactly a small molecule. 574 amino acids, they're all linked together in a string, and then they clump into a certain shape according to the code that there's in them. It's all down to the code. Their order determines their shape. So it's not just any old shape. So they're actually carrying information. They physically shape to do a job in the cell. And the hemoglobin, of course, one writer called it a 4-door taxi, which is really good. I mean, he described it so well. He said it's like 4 segments. Each one has got an iron atom in it, and they come up into the lungs, and as you breathe in, the oxygen comes flooding in. The first oxygen atom that wants to get in the taxi has to struggle, because the iron atoms have to be protected from the body because they're toxic. So they're surrounded by all this this stuff, these amino acids, to protect the body from the iron. So the oxygen has to bash its way in, And as soon as one gets in, all the taxi doors open and all 4 can go in. And 4 oxygen atoms go in that. So it's a good job you got 270 million of them for every red blood cell, or you would take a long time getting your breath. Those taxis then go flooding down. They take about 20 seconds to get to where they're going. I was amazed at that. 20 seconds to get to where they're going. When they get there, the taxi doors fly open, out comes the oxygen atoms, and in comes the carbon dioxide atoms, and amazingly, iron bonds, also, it's irreplaceable. We don't have a lot of it in us, but if you've got too little of it, you get in trouble. Anybody who has had iron deficiency will know that, because it not only takes the oxygen, it brings back the carbon dioxide. So you go, you have no idea what is going on in your blood while that is happening. But I mean, this is so complicated. I mean, this is just one molecule, and you could go through loads of them. And here are a few more machines, just for fun. We looked at that one the other week, the kinesin linear motor that goes marching down little roadways in the cell in order to deliver a bundle of proteins. It's got 2 little feet on the bottom. It's got a couple of pads that hold this great big bag on top that is proteins that it's taking. It's kind of like a cargo carrier. It marches down these microtubules driven by a kind of cell electricity. This one here, I find it interesting. They're so unlike each other. That is cytoplasmic dynein. That goes the other way. I mean, it looks like a couple of chicken legs to me, but they all fold according to their function. So the order that they're put together in the ribosome then determines what they become. I mean, who worked all this out? Who did the blueprint for this? Who did the DNA so that the DNA formed the amino acids that form the proteins that make everything work? That one there I just put up there. Oh, sorry, didn't mean to do that. That one up there I put for good measure. That's a DNA helicase, and I think that's how you pronounce it. It's like a donut with 6 sections on it that goes spinning round and round the DNA to unravel it so that it can take the RNA off it, and then there's another one that comes along and wraps it all back up again. So that's another protein machine. So you see how complicated, this is so complicated. And people talk, so if you're at school and, and people talking about evolution, try and work out a good question. Don't embarrass your teachers, obviously, but, how did that evolve? Where did that start? Where did that process start and so on? There is no known way at this moment, scientifically, that life could start from scratch on its own. All the rest is smoke and mirrors. All the rest is the emperor's new clothes. We've been told that it's true, and we keep being told it's true until in the end everybody says, oh, it must be true. No, it isn't. So that's half of that. But what about even if you had that, how would you then add complexity to it? Well, this is the current theory. Obviously, they've discovered now, Darwin didn't know anything about DNA or proteins or any of that stuff. He didn't know anything about the structure of a cell at all, really. He just thought it was a blob of living gel or something like that. But how would you? Well, we know now that to do any effective change in any living thing, you've got to change its DNA. And they've discovered that DNA does occasionally mutate. Considering how long it multiplies, it doesn't mutate that much, but it does mutate. It's got lots of duplication in it, so to some extent, that means that when your DNA mutates, you don't immediately fall down dead. But they discovered that it does mutate, and once in a while, though I've not yet seen the evidence for this, they say that it works out lucky, and you get a mutation that works for the good. So the theory is that with millions of years and loads of mutations happening cumulatively over a long period of time, slowly you could mutate the DNA, and it would turn from something that was not so good into something that was better. Well, you've got to have a lot of faith to believe that. Evolution, therefore, has slowly done it because obviously we're here, so it must have done. Or we're created. That is officially known, I hope I haven't done it an injustice, that is officially known as the Neo-Darwinian synthesis. That really came about as scientists began to discover about DNA and all these other things and mutations, and felt that maybe mutations were how it had happened. However, the problem is DNA contains information. I put a few examples of it there. It is not the medium that is important. It is the code that it carries. So you've got a binary code down there in the bottom left-hand side. You've got a Windows program. You've got a book. I mean, a book is a code. You know, it's just got 26 letters that just keep getting arranged in different groups and so on, and you can read it and make sense of it. That's all it is. You've got a DVD that's got some kind of I think it's probably a binary digital code. It is, isn't it? Binary digital code on a DVD, and it reads the sort of the dots and the dashes in the thing, and it can translate it into picture or music or whatever. It is not the plastic of the DVD that is important. It is the code. It's the intelligence. You know, somebody has to make a code. They don't just happen. And if you try and muck about with a code and change it and alter it, you will probably mess it up. If I tried to change my Windows program on my computer by kind of kicking it a bit, or, you know what I mean? Anybody ever tried to do that? Maybe you have. You would probably not improve it. You know, I'll drop it on the floor and see if that'll improve it. But that's the kind of thing, you know, external stimuli that have slowly changed the genetic structure of these things. And so it's all come on. But you can't. You can't change a code bit by bit, slowly but surely, sporadically, from random sources without making it into a nonsense. There is so much information in biology. And this is what one of the things that Michael Denton says in his book. Is it really credible that random processes, I mean, he's a fully fledged doctor, you know, with about 3 doctorates, so he's a scientist. Is it really credible that random processes could have constructed a reality, the smallest element of which, a functional protein or gene, which of course now we all know about, is complex beyond our own creative capacities, a reality which is the very antithesis of chance, which excels in every sense anything produced by the intelligence of man. Is it credible that random process could do that? Could make technology that goes way beyond anything that human beings have mastered, even now, even in the 20th century. So evidence, I've spent most of my time on this, hope you'll bear with me. Evidence of complexity then, there is no simple kit of parts. They hoped they'd find a load of Lego bits in biological systems that they could just rearrange in different ways, and in a sense they've got all those bits there, but of course it's all interwoven with such complexity that there is no way that they can so far see that life could have started from ordinary chemicals, even to form the, you know, they talk about proto-cells, but nobody, actually, how would a proto-cell actually live? How would it survive? How would it multiply? And so on and so on. And neither do they have any idea of how these simple forms could maintain themselves while evolving into ever more complex forms. And that's what you've got to do. You've got to make it, you know, it's not just a question of degenerating downwards, you've got to go upwards. You've got to go from an amoeba up to a man. You've got to add loads of information onto the program. Okay, mathematical probability. This won't take me very long. That's a Rubik's Cube, as you all know, I'm sure. A Rubik's Cube has got 27 basic components. Anybody ever managed to do that? There are 33 million different combinations with 27 components. Well, I mean 28 if you count the central core. I think I'm probably right now. But anyway, it's not that many. But even with that few components, they are capable of being arranged in so many, which means that if you were to close your eyes and twiddle with your Rubik's Cube, you would probably not get it out. You've got a 1 in 33 million chance. And every time you twiddle them again, you actually start from square one, from the base, up. So it's extremely difficult. Even if you used all of your considerable intelligence, and I did have a book that helped me to do it, and I managed to do it with the book, but I couldn't do it without the book. Even if you were to use all your considerable intelligence and you were able to do one different combination every second for the whole of recorded time, that is, even if time was 4 billion years old, if you've been doing it for 4 billion years, you would still have not gone through all the different possibilities. There is a possibility you might not have got it out just by pure chance. I mean, mathematically, it shows the immense unlikelihood of things of not huge numbers actually happening and working out right randomly. This is only 27 or so components. Now, when you look at DNA, I mean, you're in a different ballpark. And, okay, you could say there are some possibilities with DNA. There are different combinations of it. It could have a few mutations and things like that. But there are 3,000 million bits of information on a string of DNA. Your DNA, if it were laid out end to end, is actually 6 foot in length. Now, remember we said that the cell, a living cell, is so small you get hundreds of them in a square millimeter. So into that tiny little cell, your DNA is 6 foot long. However, it is very well packaged. I mean, look at, I think this is the best picture I've come across on the internet. It starts with a double helix. It's made like that so it can be unzipped and a copy can be taken from it. So it's very clever. But the double helix is then taken and wound around those, I think they're called some sort of somes. Yeah, something somes. They're kind of paddy bits that sort of that wrap it around, and then it wraps around into that and forms a spiral like that, and then goes down there and spirals like that, and then you can see there at the bottom, that section is the bottom of an X chromosome. So, I mean, it is phenomenally packaged, but every time you need a protein, you have to unpackage it, get it out, unwind it with your DNA helicase, and off you go and make it. I mean, that's just very, well, I've already said that, it's very complicated. The DNA codes for 50,000 proteins at last count. I've heard it said that there are 100,000 different proteins that go to make up living tissue. 100,000. Well, say 50,000. We'll sell for 50,000. Now, you think if the likelihood of getting a Rubik's Cube out with only 27 components is 33 million to 1 against, what is the chances of luckily getting your DNA right and then keep adjusting it randomly through millions of years so that it keeps on coming out right? Well, I've said that. What is more, they've now found that the DNA has got 4 different layers of code in it. When I heard the scientists talking about it, I thought that's too complicated. I can't quite understand that. But I mean, it does mean that you can't easily muck about with it without mucking up something else in it. So the complexities increase and abound. Sir Fred Hoyle, mathematician, has said that the chances of life arising by chance are 1 in 10 to the 40,000. That's what he calculates it as. Well, 1 in 10 to the 40,000 is a 1 with 40,000 noughts after it. Now, 40,000 noughts after a number makes it an extremely big number. So 1 to the 40,000 is so incredibly huge. Mathematically, as I say, it is impossible. Scientifically, it is impossible that life could have arisen by chance. He then goes on, unfortunately, to suggest that, like Michael Denton, it might have come from outer space. It's not solved the problem. I mean, how did it happen out of space? If it didn't happen down here and couldn't, how's it going to happen on some comet somewhere that's going to evolve itself? Okay, moving on. Number 3, stability of the species. I put that picture up there because it was once thought, they decided to work out how the whale came about. And I think at one point they thought it might be a cow that did it. Yeah, I mean, because it's a mammal, you see, it's a retrograde. It's supposed to have come out of the water and gone onto the land. How do you get a mammal back in the water again? Sort of warm-blooded and all these kind of things. So it's a dilemma. How do you find a creature that could have done it? And they came up with a cow, which had such a funny, in my mind, I thought of Daisy the cow, going for a swim one day and thinking, God, I like this, I'll carry on a bit more, until I grow a fin or two or something like that. And how many generations of cows have got to keep going swimming before they turn back into a whale? When you actually think about it, it's ridiculous. Now, I don't want to make light of it, but I mean, more modern thinking has now come, and that's Pacicetus. I think that's right, something like that. He is the front runner for it, because of course he's a bit nearer on the scale. You know what I mean? He's a water-based thing, and I think he must be a mammal. And so it's thought, well, he could be a real kind of thing for it. But in fact, we never actually see that. We never see anything growing into anything else. Oh, look, that should have come on bit by bit. That's a centaur there. There are no half and half creatures. Such a thing has never been observed. Sorry, I was going to go through this one at a time. As it is, you've got the whole lot all come out in one thing. Creatures can't reproduce across normal boundaries. I mean, a cat won't go with a dog. They haven't been able to breed it at all. They can't mix the sperm and the eggs. It's as if biologically each knows what it is and it won't mix up. Now, somehow you've got to break that rule that is universally observed everywhere. You've got to break that 1,000,000 times. You've got to break it again and again. There's no evidence for it. You can't find it anywhere. Missing links in DNA couldn't do it. Well, as we say, this should have happened millions of times. There is no evidence for it. So biologically, the argument against evolution, all they've got are the fossils, which are all dead animals. You know, the dead animals are not changed into other animals, and they can't find any. I mean, there are some that they say are missing links, but all they've done is arrange them in their row. You know what I mean? If you get something between a man and a monkey, you say, well, that's obviously a Neanderthal or a primitive man. But of course, it might just as well be a more advanced monkey. But you don't know. You've got to work that out. But it is what it is. It's not growing from one thing to another, and there's no evidence that that happens. Now, there is natural selection. Darwin saw it. I mean, he saw it with pigeons. I think dogs illustrate it better. I mean, dogs have got a phenomenally rich genome, massive quantity of different variety in a dog genome. It feels like that's part of the purpose. Not all animals have got that. But dogs certainly have got it. And from a dog kind, you can breed loads of different dogs. So we know that we know there's artificial selection, so we know there'd be natural selection. The dogs, when they go with one, could have all kinds of varieties and so on. So, well, there you go, I said that. But this is selection and not creation, notice. So natural selection, artificial selection, you are taking an animal and you are selecting some of its genes and you're mixing it with another animal and selecting some of their genes, and you're coming out with a kind of hybrid of the two. Of course, you call it a pedigree, but I mean, actually, it's a hybrid, really. But it's a diminished creature. It's got less genes than the parents had. You've actually selected them down. You see what I'm saying? Now, Darwin thought, oh, that's evolution. He saw the finches on Galapagos. It's not evolution. It was degeneration. They were hybridizing down, and their genes actually were diminishing. They were having less genes. That's why now they're keeping loads of wild stocks of plants in laboratories all across the world, because we're afraid that some of our hybridized plants won't be very good, and they might go extinct, and then we'll have to go back to the stock of the original ones that they came from. So pedigree dogs, it's interesting, and you'll sort of find this now. Pedigree dogs are often degenerate. They often don't survive very well. They often have issues. There are some dogs that the Kennel Club now won't accept as part of their sort of doggy breeds because they feel that they're too, certain. I think Dachshunds have problems with their backs, and Bulldogs have problems with their faces all being screwed up. And I think I'd have a problem if I had a face like a Bulldog, but there you go. So the evidence is, you see, that where there is any kind of development, and there is some, it tends to be degenerate. It tends to go downwards. Now, no amount of degenerate devolution is going to bring forth molecules to men. What you need is progressive. We can't find any way to make it go upwards. It only goes downwards, which is interesting because that's exactly what the Bible says. So natural selection can weed things out, but it can't actually drive evolution. Okay, now related to that, my last point, quite brief, and that is the second law of thermodynamics, otherwise known often as the law of entropy. Anybody familiar with this term? Yes. Some will be. Okay, some will be. Well, let me take you through it. The first law of thermodynamics states that nothing can be either created or destroyed in a closed universe. In other words, there is so much stuff in the universe, and that's it. You can convert some of that stuff into something else. You can convert matter into energy or energy back into matter, but you can't actually get rid of anything. If you use the sun as an illustration, the sun's heat is constantly going out into the universe and dissipating. but it's never lost. It's all, you know, it's some far galaxy is getting a little bit warmer because the sun's heat's getting there. You see, well, that's the first law of thermodynamics. Nothing is ever lost. You can burn it, but you just change it into different things, into gases and ash and stuff like that. Even nuclear thing converts matter into energy rather suddenly, but it's not lost. It's all still there. That's the first law. The second law says that although it can't be lost, it's becoming less useful. So the sun's heat that is spreading out from the sun is slowly dissipating through the universe, and the sun, as a result, is slowly running down. Nothing's lost, but everything's running down. It's all like a clock that was wound up, and it's all slowly everything's running down. That's the second law of thermodynamics, and you find it actually everywhere. You know, if you go away and leave your house and your garden for a year, you will not expect to come back and find it looking neater than when you went away. You know, and I know that's a sort of silly illustration in a way, but we observe that all the time. It's the kind of law of decay. Everything is running down. It's not lost, but it's running down and is becoming less. It's the kind of energy in it is going. And I mean, eventually they say the whole universe will be one temperature, the universal temperature all over, and nothing will move and everything will die. So we talked about the sun's heat. So that's the law of entropy. That's the second law of thermodynamics. Now what we find when we look at evolution is that it totally obeys the second law of thermodynamics. I mean, obviously life offsets that. You know what I mean? Life, you know, gravity will pull a plant down, but life will make it grow up. At least not some of my plants, they keep falling down, but you know what I mean? There's a kind of, so there are contrary laws that, but in the end, entropy works out and wins out. So everything slowly dies. All creatures are slowly degenerating. I read a very interesting book on the genome by a genetic scientist, and he said it is the undisclosed secret of genetics that the genome of every living thing is slowly degenerating. The human genome is degenerating by about 100 mutations every generation. So I've got 100 more mutations than my parents. My parents have got 100 more than their parents, and so on. My children have got 100 more than me. I think I've got that the right way around. Anyway, generation on generation, we end up with more mutations. Now, the fact that the genome is so rich and there is so much duplicate information in it means that we don't, as it were, as I say, all fall down and die, but it does mean that cumulatively, over a long period of time, we might well expect to see that human beings, we might go back far enough, we might see that far from human beings being primitive, they were actually more superior than we are. They might even have been brighter. They could well have been stronger, and so on and so on. So it may be that this is the cause of why all sorts of illnesses are beginning to pop up in spite of medical science and all the things that it could do. We don't know for certain, but it could be. In Romans 8 verses 20 to 21, it actually says that the whole earth is degenerating, is in bondage to corruption and decay, and will be until one day God redeems it. So the earth began perfect, fell, and then is slowly going down. So it'd be irony, wouldn't it, that Darwin saw the evidence of a world degenerating and thought it was evidence of a world progressing. Now those two things are irreconcilable. It is either degenerating or it is progressing. My suggestion is that it is actually degenerating. That's why we see increasing numbers of species in the world. I suspect there may be other things as well, I agree with that, but there are currently, according to the World Wildlife Fund, something over 16,000 species that are endangered. Many, of course, have died out that we know of. There's a great hustle. I mean, almost every nature program now is about saving the planet. The planet is... Now, if this evolution was such a powerful model, we might expect that actually we wouldn't worry. We say, well, don't worry, we'll lose a few, but more will evolve. Well, they're not. They're dying. They're dying because the whole world, as it were, is under that kind of judgment. So why is it then, finally, my final remarks, why is it that so many scientists support evolution? That is Richard Lewontin. He's quite a well-known professor. I think he's still alive. This is what he says. It's a bit of a mouthful, this, but try and follow it if you can. We take the side of science in spite of the patent absurdity of some of its constructs. Patent absurdity of some of the things that it says, in spite of its failure to fulfill many of its extravagant promises of health and life. In spite of the tolerance of the scientific community for unsubstantiated just-so stories. You think, well, it could have happened like this, and then it becomes proof. You know, well, that's not proof. Because we have a prior commitment, a commitment to materialism. We are not willing to countenance a spiritual dimension to life. It has to be materialistic and it has to be natural. It is not that the methods and institutions of science somehow compel us to accept material explanation of the phenomenal world, but on the contrary, that we are forced by our a priori, in other words, we've already made up our minds, our a priori adherence to material causes to create, I mean, he is a bit of a professor, you can tell, can't you? I'm sorry it's a bit of a mouthful. Create an apparatus of investigation and set of concepts that produce material explanations. In other words, we've geared the whole thing, science, so that it only produces material understanding of anything. It doesn't come out with a spiritual. Scientists are not going to say, well, maybe God did it. They will not say that. The whole of science is geared, so that's the one thing they will never say, even though they're faced with loads of different problems and so on. No matter how counterintuitive, no matter how mystifying to the uninitiated. Moreover, this is the bit I've underlined, that materialism is an absolute, for we cannot allow a divine foot in the door. And that says it. Scientists are men like the rest of us. And they've decided that they don't actually want to bring in that sort of spiritual dimension. It complicates their lives. I might like the idea that God loves me, but I might not like the fact that I've one day got to face him. So men bury their head in the sand and say, if we ignore him and don't allow him in our arguments, then he will go away and not be there. Michael Denton, I think I'm nearly at the end now. Now, this is a good one. Right at the end of his book, the influence of evolutionary theory on fields far removed from biology, as we've already said, is one of the most spectacular examples in history of how a highly speculative idea for which there is no really hard scientific evidence. I didn't say that, he said that. A highly speculative idea for which there is no really hard scientific evidence can come to fashion the thinking of a whole society and dominate the outlook of an age. I think he's spot on right. That's exactly what has happened. We can choose whether that is so for us. We can be a nonconformist. We can say, hang on, I don't agree with that. I've got a question about that. You know, you don't have to make a big song about it, but certainly it's worth checking it out. It's worth being curious. Okay, issues with evolution. Evidence of design, that's the first one that I spent a lot of time on. Mathematical improbability, that's the second. Third one, the stability of species, we don't actually see them changing. And fourth one, the second law of thermodynamics. For me, that kills it. I'm so certain of that. And what amazes me is that this deceit has been perpetrated on an entire generation, on the whole of Western civilization, to our great cost and detriment. We have no idea how badly this has affected us. So it is really quite critical. And whenever I get a chance, I do speak of it. Good. Well, thanks, everybody. Got a nice few questions here, so we'll do the best that we can with them. The first one is a question about global warming. Are we contributing to global warming? That's the first question I don't know the answer to. I think you have to say it's possible. I am slightly dubious that there are political motives behind the global warming thing. And certainly as far as this country is concerned, we're pumping out miles less carbon dioxide, I think we are anyway, than we did in the Industrial Revolution when factories were belching out smoke and there was no Clean Air Act and anything like that. So it may have now all gone to China, but generally speaking, stuff is cleaner. There are some that know a lot more about it than I do, that think actually that it is due to periodic heating of the sun. and that the sun goes through cycles of heating. There was a time, certainly in about the 1800s, when they called the Little Ice Age, when the Thames froze over and everything for years running. So there may well be periods, and that when in the natural run of things, the sun's heat shifts and changes, and that may be part of the cause of it. But it may be that carbon dioxide is causing part of it, but we'll look at that a bit more next week when we look at a creation model, which I hope you'll be able to make it for, because next week is, I think, one of the most helpful, certainly as far as I'm concerned, that I do in the whole series. So are we contributing to global warming? Well, possibly. But the jury's out on that one. People that know more about it than I am seem to hold divided opinions. Secondly, why do so many everyday people who aren't scientists believe in evolution? Well, that I think is a bit easier to answer. It speaks really of the power of a culture to shape our minds. We think that Western culture is easygoing, liberal, and so on, but it has certain bottom lines and certain things that are very strongly held, and you find out what they are if you break them. Evolution is one of them, and as I say, we are methodically teaching our children from a very early age that first of all, that the Earth is extremely old, like millions of years old, and secondly, that it is been slowly evolving through that time, and that we have probably come from apes, things like that. I mean, Desmond Morris wrote a book, The Naked Ape, years ago, and basically said that human beings had somehow come out of the trees and started walking on all fours, and then our stature had improved and our brain had grown, and all these amazing things that happened, all at the same time to take us into a new league. Why do so many everyday people who aren't scientists believe in evolution? I think because it's strongly in the culture and people accept it. And frankly, if you don't, I mean, I've found that you may be reasonably bright, but people think you're completely stupid if you don't accept an evolutionary worldview. So that's a hard one to, unless you're convinced, you're not going to, you give way, won't you? You just kind of go along with it and say, well, maybe there was something. Now, here's one. How long ago did you believe that the world was made? Oh, that's a good one. I'll tell you what the Bible says. The Bible says 6,000 years ago. Now, we were talking to a friend the other day about that, and she said, I can't believe that. I can't believe it. I said, why not? She said, I just can't believe it. She couldn't actually tell me why she couldn't believe it. She just couldn't believe it. And again, that does speak to some extent of the programming that we all take. Nothing comes with an age on it. If you see a rock, it doesn't have an age on it. The way that they measure dating is invariably process dating. In other words, you observe a process that's happening, whether it's carbon-14 degenerating, whether it's potassium, argon, and these various substances. They've got a half-life, and they decay over long periods of time. Carbon decays over about 5,000 years. But some things have got millions of years half-lives. It's very difficult to work out a million-year half-life when you only had 10 years to measure it, I have to say. But I assume that they can do that. But all of it is process dating. You observe something happening, and you have to make a number of assumptions about it in order for it to be a date. Now, if I take a simple illustration, if you've got a bath full of water and there's a tap dripping into it, in theory, if you could measure how much water is dripping from the tap and how much water is in the bath, you could tell how long the bath has been filling with the tap. Is that right? Might be a tricky bit of maths, but you could do it. However, what you wouldn't know is whether the plug has been leaking. Whether there's been evaporation out of the system, whether somebody in the past came and tipped a bucket in, or whether somebody came and pulled a bucket out. So you would have to make a lot of assumptions that the whole environment has remained totally as it is now, as it always has been. Now, those are the assumptions that are behind all process dating. And they've now found that some of the datings are way wide of the mark. Surprisingly, they found carbon-14 in coal. Now, coal is meant to be millions of years old, and carbon-14 has only got a half-life of 5,000 years. So within 50,000 years max, you would have no carbon-14 that you could find in coal. But there is carbon-14 they've found now in coal. Nobody ever looked before. Now they've started looking and they think, oops, they found carbon-14 in diamonds. Again, they're supposed to be millions of years old. They cannot be. So they're all finding all sorts of anomalies. And there are some scientists that are saying, actually, the dating process that everybody's used are useless. They are no good. They are not fit for purpose. But of course, what often happens is when you get a very young date on something that's thought to be old, they say, well, that must have been somehow mucked up, and therefore we discount that one, and you only take the ones that fit what you already think. So there's lots of sort of stuff goes on, and it's not nearly as certain. They'll say a certain 135 million years, give or take 1 million. You think, well, that must be really accurate, you know. I mean, okay, it's a million off, but even so, in that amount, that sounds really accurate. But actually, I've discovered, certainly in my own research and others that are doing much more than I, that the whole thing is now greatly inaccurate. So I am quite happy with 6,000 years old. One of the date that was put down was 4004 BC. And so if you add that to 2018, you get 6,020 something. So, but you know, as you'll see next week, you can actually make a totally credible explanation out of that. And all of history, human history, only starts about 3,000 or 4,000 years ago, max. The Chinese date their origins to about 4,400, which is pretty well spot on the flood date, according to the Bible. And all the ancient civilizations of Babylon, Egypt, and so on, all arise around about the same period, simultaneously all over the world, which sounds awfully like a Tower of Babel and the peoples being spread all over the world and beginning to form their civilizations in the river valleys and so on. So there's a lot of stuff, lots of residue and sediment that is laid down, like say the Grand Canyon. It was originally said, well, it's millions of years old, and then the waters cut a thing through all these millions of years. It's now thought that actually it's not at all millions of years old. It was fairly recent. It's massive, great pancakes of mud that were laid down and formed a kind of mile deep of sediment. And then there was a dam broke up in the mountains. The river rushed down, huge quantities of river, and cut through the rock when it was still soft, this deep chasm. It's now hardened, and you've got a much smaller river running through it. But again, if you say, well, the present is the key to the past, then you look at it and now and you think, well, it must take millions of years. But if you think, no, actually in the past it was very different, you get some different conclusions. Next question, is it not simply that humans cannot know how life began, so we've simply made up stories to explain what cannot really be understood? That's a fair point, and I think I would say that, except, of course, that we do have some understanding of some of these processes. You know, we know what things are likely on a mathematical basis and what things are not likely. You know, if you, I mean, I've got a picture on one of my things of the figures of 4 presidents of Mount Rushmore National Park. Anybody seen that? You would probably know that picture of 4 presidents. Now, if I said to you that those shapes were carved by the combined act of wind and rain, you would not believe me. You would say that, pull the other one. Because you know when something has been specifically designed, you know, I mean, you might look up and see a cloud that is shaped like a football and think, oh, that looks like a football. Okay, we can go with that. But where there is so much specific information as there is in these statues, you would say, no, somebody did that. And of course he did. You know, he went down on a cradle and swung from side to side, going backwards and forwards, chiseling away into the mountain to make these shapes of the 4 presidents there, you know, all the detail that goes into that. Now, I think that we apply that generally. You know, they will often say, they pick up an arrowhead that looks like somebody's chipped at it and say, well, that's an arrowhead. You know, so even at that's a fairly limited level. We can tell whether something has been manufactured, whether it's had purpose, whether it's been designed, whether somebody had a plan for it. Now, when you get to things like a pocket watch, you found a pocket watch on the on the beach, you would not say, oh, that must have just evolved there. You know what I mean? It's just a lucky coming together piece of metal. You say, no, somebody did that. So we do know what something designed looks like. So we may not, and we can't work out, and we're desperately trying. I mean, scientists are desperately trying to find some way that they can find a cause for this that doesn't need a designer. I mean, Dawkins constantly says these things have got the appearance of being designed, but they're not really. But of course, they've got appearance of being designed because they are designed. That's why they've got the appearance of it. And so far, I mean, it was always thought we could find a way for this, but thus far, they haven't really. So, I mean, it's a fair question, but my own view is that when you look at it, it stacks up. There's such a lot of stuff that is saying this. You know, you would expect certain things to be fulfilled for something like that to happen by chance. And for it to happen again and again, a million times, over millions of years, the world doesn't happen like that. The next one, with large improbability of chance life come into existence, is that God did it, any higher or better chance, or just the same odds? Well, that's a good one, isn't it? Did you get that? It's a huge improbability of, well, I mean, if it didn't come by chance and God didn't do it, then we are in a pickle. We haven't really got any kind of answer to anything. I would say it's hugely more probable, but obviously you do need, and this is where all of us, you do have to have some basic assumptions. Since we don't understand the ultimate mysteries of life, and generally speaking, we don't have brains big enough to cope with it, you do have to take a few things as given. Scientists take naturalism for given. They say, it all happened naturally, that's a given, so we've got to fit around that. But if you take God as a given, if you say that there is a being beyond Earth that is outside of time and space, of immense power, intelligence, artistry, and brilliance, that has brought it all forth for a purpose, then that would actually explain a lot of things. It would explain why we're creatures of purpose. It would explain why we're people that love and feel love and need love. We're created in his image, so his stamp is sort of stamped through it all. So for me, it is hugely more likely, but we've got to build a case. I mean, I'm only at the beginning. We're 3 sessions in. Next week, as I say, we're going to try and look at other details. We're going to try and compare the Bible to facts on the ground as far as I know them. So I hope you find that helpful, and hopefully the probabilities will increase as we go along. But each of us has to judge that. We have to determine whether for us it fits. I feel comfortable. For me, it fits. And I've actually, I don't know, how many years ago? 70 years ago. No, not 70 years ago. I'm only so old. Certainly, a long time ago, I determined that I would found my life on the reality that God exists and he loves me. And I mean, that involved me in changing my whole career, becoming a pastor, a lot of changes that come to my life. I cannot imagine my life had I not done that. And I have not regretted that one bit. So I have to say, thus far, I'm totally convinced that it is true. Now, here's one with the belief in creation linked to our chronological or factual, actual recorded history. Then is there evidence of evolution since creation? And so how do you reconcile the two? That's, again, a good question. There is evidence of evolution, but my own suspicion is generally it tends to be downwards, as we've already said. So, I mean, even in the affairs of men, there was a thought that, that social evolution was a given. The Victorians thought that the human race would go on, you know what I mean? We would spread education everywhere. We would make brilliant inventions. I mean, the Victorians were on the crest of it. They were brilliantly inventive. They thought, we are, the turn of the 20th century was a time of unrivaled optimism. Of course, then came the First World War and then the Second World War, and that really put a kibosh on it. And lots of that optimism has gone. But there certainly was a time, and there have been times when the human race has gone through a golden age. Egypt went through a golden age, but then often they plummeted back down. Now, the overall drift, it may be even in terms of social stuff, but in terms of the biology, which is my main concern, and the physical environment, it is continuing to go downwards. I think. Time will tell. And that is the biblical scenario. That the world is in bondage to corruption and decay and will slide down until the King returns and he will bring it back to life again. And there'll be a new heavens and a new earth, and that sounds great. Karen, out of that, when will God decide enough is enough? I could give a short answer and say soon. But I mean, certainly there is stuff in the Bible that indicates a world not that different to the world as it is today. I mean, without going into that, because that actually comes further on in the course, the Bible actually pictures a world that is a global civilization in the last days. And to some, I mean, and every empire has moved in that direction. The Romans did, the Egyptians, Babylonians, we're all moving towards, as it were, spreading a global empire all through the world, a civilization. But it's never actually happened until now. And it hasn't quite happened, but certainly the scenario that you get with a global empire with various power blocks within it that are vying for authority with one another, that is not so far away. There are already big power blocks within the global civilization, world trade, but all this sort of stuff going on. So there is, I think, signs that it could be within our lifetime. I do like the whole talk. Oh, that's good. And praise God on how complex and wonderful we are created. Not really a question, but it would be good to have a few verses from the Bible explaining man's fallen state, Satan, the father of all lies, and the great deception in these last days, increase in knowledge, etc. Great, good question. That will all come. I shall try not to fit all that in at the end of this one, but we do have one or two specific evenings that will deal with those issues separately. My purpose with it is to try and build a step at a time, a step at a time. I mean, I'm hoping that you'll travel with me, but you may not. You may think, oh, still don't go there. That's okay. But certainly that is my approach, that we try and build it up and say, well, let's see where we've got to so far. So tonight, really, I'm just saying that as a model for the origins of life and everything else, evolution is inadequate. That leaves only one other possibility, I think, and that is that God did it. But that would be a hard step to take for many people. I understand that, and I will try to justify that as we go along. Great, well that's it. We've done all the questions that everybody asked. It's 9:10, and I am trying to finish at 9 o'clock because I'm hoping that you'll come back again next week, and I don't want you all to completely fall asleep. If anybody got anything else you want to chew over, do come and talk to me. I'll be hanging around and clearing up for a bit, and I'll be happy to do that. Great, thank you everybody. Oh, thank you.